Okay, so this next section, and this is our third video for Chapter 6, is on transforming and combining random variables. Back in the last section, we looked at examples of random variables and their probability distributions. We also saw that the mean and standard deviation give us important information about the random variable. For instance, for when X was the amount of gain on a $1 bet on red in a game of roulette, we already showed that the standard, or that the mean was a negative 5 cents. We can verify that the standard deviation is $1. That is, the player can expect to lose an average of 5 cents per dollar bet if he plays many games. But if he plays only a few games, he actually might gain, and it could be much better or worse than this expected value. So would the player be better off playing a game of roulette with a $2 bet on red, or playing 2 games and betting $1 on red each time? To find out, we need to compare the probability distributions of random variables y equals the gain from $2 bets, and t, the total gain from 2 $1 bets. And by the end of this section, we should know the answer to that. So, linear transformations. Here's an example. Eldorado Community College considers a student to be full-time if he or she is taking between 12 and 18 hours. The number of units X that a randomly selected Eldorado Community College full-time student is taking in the fall semester has this distribution. Calculate and interpret the mean and standard deviation. Well, we already know how to do that. That was from the last section. So here we go. These are the number of units, and this is our distribution. Note the shape of this. All right, so now the mean can be calculated by multiplying the random variable units by their probability and adding those together, and we get 14.65. To find the standard deviation, we first find the variance, which we find by taking each value for X and subtracting the mean, squaring it, and multiplying it by its probability, and then summing those all together. And when we do, we get 4.23. Now remember that that's the variance, it's not standard deviation. To find standard deviation, we take the square root of that. Okay? All right. So, new problem. All right? At Eldorado Community College, the tuition for full-time students is $50 per unit. So, I'm going to multiply all those units by 50. That is, if T equal tuition charge for randomly selected student, T equals 50X. Here's the probability distribution for T. So all of our X values were multiplied by 50 to get the T values. So let's take a look at that distribution. Okay, that's our original one. Is there a change? Nope, it's the same distribution. Okay, exactly the same distribution, does not change. Now we got tuition charge instead of unit. Okay, so let's calculate and interpret the mean and standard deviation. All right, so the mean of T, again, we multiply our values for T by the probability and add those all together, and we get $732.50. To find the standard deviation, again, we're going to take our random variable x and subtract the mean, square that, and multiply by their probability. And then sum those all together, and we get 10,568. Now, remember that is the variance. So, to find the standard deviation, we take the square root of that, and it's $103. So what is the effect of multiplying and dividing a random variable by a constant? Remember, we multiplied by 50. Well, the shape of both distributions are the same. Second, the mean of the distribution of t is 50 times bigger than the mean of x. So 732.50 equals 50 times 14.65. And of course 50 is what we multiplied our x by. The standard deviation of t is 50 times bigger than the standard deviation of x. So 103 is 50 times 2.06. Okay, that was the last one. I skipped one. All right, so our next problem. In addition to tuition charges, each full-time student at El Dorado Community College is assessed student fees of $100 per semester. If C equals the overall cost for a randomly selected full-time student, C equal 100 plus T. Here is the probability distribution for C. Okay, so we added 100. Now, calculate and interpret the mean and standard deviation. Well, first I want to look at my probability. Remember that's a probability distribution. Remember, that's our first one. Multiplying by 50 didn't change it. And guess what? Adding 100 does not change it either. So, calculate and interpret the mean and standard deviation of C. Okay? The mean, again, we multiply each value times its probability, and we get $832.50. Our standard deviation, again, we take each value and subtract the mean, square it, multiply by the probability, and add those all together, and we get 10,568. So, again, we're going to find our standard deviation. Remember, this is our variance. So standard deviation is, we take the square root of it, and we get $103. So what is the effect of adding or subtracting a constant to a random variable? Well, as you can see, we added $100. We added 100 to our mean. Our last mean was $732.50, and our new one is $832.50. So, added 100 to our mean. The standard deviation is the same as it was for C. So there's no difference in the standard deviation. Okay. Check your understanding, okay? So now would be a good time to stop this and check your understanding on page 362. All right. So, suppose the dealership manager receives a $500 bonus from the company for each car sold. Let Y be the bonus received for car sales during the first hour. On a randomly selected Friday, find the mean and standard deviation. And that is, mu is $550, and the sigma or standard deviation is $471.50. To encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit T on a randomly selected Friday is the bonus earned minus $75. Find the mean and standard deviation. Okay? Remember, the standard deviation should not change by subtracting $75. So the mean is $475. Okay. So, let's put this all together. What we have done is linear transformations. That's what these are called. So what is a linear transformation? Well, in general, a linear transformation is of a random variable includes both transformations that we saw in Chapter 2, multiplication and or division, and addition and subtraction. And it can be written in the form y equal a plus bx, where a and b are both constants. If y equals a plus bx is a linear transformation on the random variable x, then the shape, neither transformation, multiplication or division, or addition and subtraction will change the shape. It's going to stay the same. The center, which is our mean, can be written that the mean of y is a plus b times the mean of x. So the mean will be multiplied or divided by b, or increased or decreased by a. So the standard deviation is multiplied by the absolute value of b, because b could be negative, and is unchanged by a. Okay, here is an exam common error. When asked about the effect of linear transformation on summary statistics, don't forget that adding and subtracting a constant to or from every value in a distribution has no effect on the measures of spread, which includes standard deviation, variance, range, and interquartile range. So adding and subtracting, multiplying, and dividing does not change that. I'm sorry, adding and subtracting doesn't change that. Multiplying and dividing does. Okay. All right, so here is an example. In a large introductory statistics class, the distribution of X equal raw scores on a test are approximately normally distributed with a mean of 17.2 and a standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and adding 10. So we're going to define the variable to be the scaled score of a randomly selected student from this class. Find the mean and standard deviation of y. Okay, remember X is the raw scores. So, since y equals 10 plus 4x, then the mean of y is also 10 plus 4 times the mean of x. So we've got 10 plus 4 times 17.2 is 78.8. And the standard deviation, remember that adding does not affect the standard deviation, only multiplication does. So we don't have to worry about the plus 10. Just do 4 times the standard deviation of x, and we get 4 times 3.8, which is 15.2. What is the probability that a randomly selected student has a scaled test score of 90? Well, let's look at that distribution. There we go. There's our normal curve, and we're talking about it has a 90 or better. Okay, so there's our normal curve. So remember that we're going to standardize this, okay? Since transformations do not change shape, y has a normal of 78.8 as our mean and 15.2 as a standard deviation distribution. So standardize the score for a scaled score of 90. So z is equal to 90 minus our mean, 78.8, divided by the standard deviation, 15.2. And when we do that, we get 0.74. So according to table A, the probability of z less than 0.74 is 0.7704. So, what does that mean? Well, remember that we're looking for above the or greater than 0.74, so we need to subtract that from 1, and we get 0.2296. So the probability is 0.2296 that a randomly selected student has a scaled score of at least 90. Okay? The end.